In the bustling city of Basra, located in what is now modern-day Iraq, a brilliant mind was born around the year 965. This was the Islamic Golden Age, a time of, great intellectual curiosity and scientific advancement across the Muslim world. The man born in this vibrant era was Abu Ali al-Hasan ibn al-Hasan ibn al-Haytham, who would later be known in the West as Alhazen. He grew up in a world that really valued knowledge above all else. Libraries and academies flourished, and scholars from different cultures came together to translate, study, and expand upon the wisdom of ancient civilizations, especially the Greeks. Ibn al-Haytham was a product of this remarkable period in history. His early education was extensive and diverse, reflecting the scholarly environment of his time. He studied theology and law, preparing for a civil service career as a minister in Basra. However, his true passion lay elsewhere. He was deeply fascinated by the natural world and the universal language of mathematics. He read the works of Greek thinkers like Aristotle, Euclid, and Ptolemy, but he wasn't content to simply accept their ideas. He questioned everything, driven by a powerful desire to find truth through direct observation and experimentation. This critical mindset set him apart and paved the way for his future scientific breakthroughs. A famous story tells of a bold claim he made that would change his life forever. Ibn al-Haytham believed he could build a structure to control the annual flooding of the Great Nile River. This ambitious proposal reached the ears of the Fatimid Caliph in Cairo, al-Hakim bi Amr Allah. The Caliph, who was known for his eccentric and often unpredictable nature, summoned the brilliant scholar to Egypt to turn his theory into reality. Ibn al-Haytham traveled to Cairo full of confidence. He was ready to take on this monumental engineering project, one that promised to bring stability and prosperity to the lands along the Nile. However, upon arriving in Egypt and seeing the mighty river firsthand, he realized the immense difficulty of his plan. The scale of the project was far greater than he had imagined, and the technology of the time just wasn't advanced enough to succeed. Fearing the wrath of the powerful and volatile Caliph al-Hakim, Ibn al-Haytham had to admit his failure. To escape punishment, he cleverly feigned madness. The Caliph, instead of executing him, placed him under house arrest. This period of confinement, which lasted for about 10 years, turned out to be a blessing in disguise for science, providing him with the time and solitude needed for his most profound work. It was during his long years of house arrest in Cairo that Ibn al-Haytham produced his masterpiece, the Kitab al-Manazir, or Book of Optics. This 7-volume work completely revolutionized the understanding of light and vision. Before him, the prevailing theory from ancient Greek thinkers like Euclid and Ptolemy was the so-called emission theory. This theory suggested that our eyes send out invisible rays that strike objects, allowing us to see them. Ibn al-Haytham found this idea, honestly, illogical. He argued that if our eyes emitted rays, we should be able to see in the dark, which we clearly cannot. He proposed a new radical idea. He correctly explained that vision happens when light reflects off an object and then enters the eye. This was the intromission theory. He wasn't the first to suggest this, but he was the first to prove it with rigorous experiments. He used a camera obscura, which is Latin for darkroom. He showed that when light passed through a tiny hole into a dark chamber, an inverted image of the world outside appeared on the opposite wall. This simple but elegant experiment demonstrated that light travels in straight lines, and that vision is a passive process where the eye receives light rather than actively sending it out. Ibn al-Haytham's work went far beyond just explaining how we see. He meticulously studied the anatomy of the eye, identifying parts like the cornea, lens, and retina, and described how they work together as an optical system. He investigated phenomena like reflection and refraction, explaining why a spoon in a glass of water appears bent. He also explored optical illusions, understanding that our brains play a crucial role in interpreting the signals sent from our eyes. He was one of the first to blend physics, anatomy, and psychology to create a complete theory of vision. His approach to science was just as important as his discoveries. He is credited with developing and promoting the scientific method. He insisted that any scientific claim must be supported by evidence from experiments and systematic observation. He would state a clear hypothesis, test it through carefully designed experiments, and then analyze the results to draw a conclusion. This methodical process of inquiry, questioning, experimenting, and proving is the foundation upon which all modern science is built. His book of optics was not just a book of conclusions, it was a guide on how to do science. Ibn al-Haytham is most famous for his work in optics. His intellectual curiosity was honestly boundless. He was a true polymath, making significant contributions to many other fields, especially mathematics. He was deeply engaged with geometry, building upon the work of Euclid. He wrote commentaries and even attempted to solve complex geometric problems that had puzzled mathematicians for centuries. One of his notable efforts was his work on what became known as Alhazen's problem, a geometric challenge involving finding the point on a spherical mirror where light from one source will be reflected to an observer's eye. His mathematical explorations also extended into number theory. He studied perfect numbers, which are positive integers that are equal to the sum of their proper divisors. For example, 6 is a perfect number because its divisors 1, 2, and 3 add up to 6. He was one of the first to state a theorem about these special numbers, a concept that would later be explored by European mathematicians like Pierre de Fermat. His ability to move between different branches of mathematics really demonstrated his incredible versatility and his deep understanding of abstract principles that connected different areas of knowledge. Astronomy was another field that captured his attention. The stars and planets were a source of wonder and a subject for rigorous scientific study during the Islamic Golden Age. Ibn al-Haytham wrote critiques of the astronomical models proposed by the ancient Greeks, particularly Ptolemy's model of the universe. While he accepted the idea that the Earth was the center of the cosmos, he found the mathematical mechanisms Ptolemy used to describe planetary motions to be physically impossible. He argued that the movements of celestial bodies must obey the same physical laws that apply on Earth. His book, Doubts on Ptolemy, challenged the established astronomical framework and encouraged future astronomers to seek better, more coherent models. He argued for a physical reality in the cosmos, not just a mathematical one. Although he didn't propose a new model himself, his critical analysis laid important groundwork for later astronomers, both in the Islamic world and in Europe. His insistence on physical consistency in astronomical theories was a crucial step toward the revolution that would later be led by figures like Copernicus and Galileo, who also sought to understand the true nature of the heavens. After the death of Caliph al-Hakim in 1021, Ibn al-Haytham was finally released from his long house arrest. He spent the rest of his life in Cairo, living near the famous Al-Azhar Mosque and University. There he earned a living by copying scientific manuscripts and teaching, continuing his scholarly work until his death around the year 1040. During these final years, he really solidified his reputation as one of the greatest scientific minds of his time. He left behind an immense body of work, with estimates suggesting he wrote over 200 books and treatises on a vast range of subjects, though only about 50 have survived. The influence of his work, especially his book of optics, was profound and long-lasting. In the 12th and 13th centuries, Kitab al-Manazir was translated into Latin, making his revolutionary ideas accessible to European scholars. It became a standard textbook on optics in Europe for hundreds of years. Scientists like Roger Bacon, Leonardo da Vinci, and Johannes Kepler all studied his work extensively. They built upon his foundations, with Kepler eventually developing the modern theory of the retinal image. Ibn al-Haytham's ideas directly paved the way for the invention of eyeglasses, telescopes, and cameras. For these groundbreaking contributions, Ibn al-Haytham is rightly known as the father of modern optics, but his legacy is even greater than that. He's also considered one of the fathers of the scientific method. His relentless insistence on experimental proof and empirical evidence transformed science from a philosophical pursuit into a systematic investigation of the natural world. He demonstrated that knowledge shouldn't be based on authority or tradition alone, but on what can be observed, tested, and verified. This principle is the very heart of scientific progress. His story is a powerful reminder of the brilliance that flourished during the Islamic Golden Age and its crucial role in shaping our modern world. From a prison cell in Cairo, Ibn al-Haytham changed how we see the world, both literally and figuratively. He taught us to look at light, vision, and the universe itself with new eyes. And more importantly, he taught us how to look. His life and work stand as a timeless testament to the power of human curiosity, critical thinking, and the unending search for truth. His light continues to shine brightly in the history of science.